Systems are built to solve problems, and you'd think that as they get bigger, they just get better at it. But so often, the opposite happens. They actually get worse. So why is that? Why does a system designed with a clear purpose seem to lose its effectiveness as it scales up? Well, that's what we're going to break down here, the hidden logic that drives this very predictable decline. So here's the expectation versus the reality. On one hand, we expect growth to lead to improvement. It seems logical, right? More resources, more scale, better results. But the reality is often very different. What growth really introduces is complexity. And complexity isn't neutral. It's a force that can actively undermine a system's original mission. Okay, to really get how this complexity works against a system, we have to look at its most basic structure. It turns out that at the heart of any large system, there's this core relationship between two very fundamental roles. Every system really breaks down into these two roles. You have the principals, they're the ones who set the goals and define what the system is supposed to do. And then you have the agents. They're the ones actually on the ground, doing the work to make those goals happen. This division of labor, it's essential for any system to grow. But that very separation creates an inherent tension. It's something known as the principal-agent problem. You see, the goals of the principal and the day-to-day reality of the agent, they don't always line up. And here's the crucial part. The agent, who is right there doing the work, always has more information than the principal, who's at a distance, and that creates a fundamental information gap. Now, this tension, it's not just about having slightly different goals. It's about a really deep, fundamental trade-off. The priorities of the principal and the agent are often in direct competition, and they pull the whole system in two opposite directions. If you look at it from the principal's perspective, from that high-level view, the system needs to be predictable. It needs to be flawless. They're ultimately responsible for the outcome. So their priority is always going to be thoroughness and control, anything to stamp out the possibility of an error. But the agents, they live in a totally different world, a world of limited time, limited resources, and constant, immediate pressures. So their reality forces them to optimize for something else entirely, efficiency. They have to find the quickest, most practical way to just get the job done. And right there, that's the direct conflict. The principal's demand for thoroughness, that means slow, careful, predictable processes. But the agent's need for efficiency, that means speed, adaptability, sometimes even shortcuts. The thing is, a system can't perfectly maximize both at the same time. Getting more of one almost always means you get less of the other. This core tension actually has a name. It's formalized as the efficiency-thoroughness trade-off, or ETTO for short. And it's not a flaw. It's just an inherent property of any system that has to work with finite resources. When you push for more productivity, you're naturally going to reduce thoroughness. And if you demand more thoroughness, you're going to slow things down and reduce efficiency. So how does a principal try to manage this trade-off, especially from a distance? Well, they turn to their most powerful tool, creating rules. Rules are the mechanism they use to try and enforce thoroughness, to standardize what the agents do, and to try and squeeze out any unpredictable results. But here's the thing. The way rules get added to a system isn't random at all. It follows a very predictable one-way pattern, and this pattern has a powerful and often a very destructive effect over time. This pattern has a name too. It's called instruction creep. It's this slow, gradual accumulation of rules, instructions, and procedures. And the tricky part is, each new rule, when you look at it by itself, seems totally logical. But the cumulative effect, that can become completely unmanageable. Let's walk through how this happens. A new system almost always starts out with simple procedures. The link between a rule and the goal is obvious, and the agents have plenty of flexibility to actually do their work. But then, inevitably, something goes wrong. Maybe it's a small error or some weird edge case that nobody thought of, something the original rules just didn't cover. From the principal's point of view, this is a failure of control. And the response seems perfectly rational. To stop that specific error from ever happening again, the principal adds a new rule or a new step in the procedure. It's a direct, logical attempt to increase thoroughness in response to a real, demonstrated failure. And just like that, the cycle starts. Every new error, no matter how small, triggers the exact same response. Add another rule, add another checklist, add another layer of procedure. But here is the absolute key to the whole process. It only goes in one direction. Adding a new rule feels like you're adding safety and control. But removing an old rule, that feels like you're reintroducing risk. So what happens? Rules almost never get taken away. The system effectively becomes a rule ratchet. It can only click forward, adding more rules, but it can never go back.
So what's the long-term effect of this rule ratchet? Well, it's not a safer, more thorough system. Instead, what emerges is a system-wide dysfunction, one that nobody actually intended to create. This phenomenon is called goal displacement. As the web of rules gets more and more tangled, the actual job of the agent begins to change. It stops being about achieving the system's original purpose. Instead, it becomes about successfully navigating all the rules. The new mission is simply compliance.
And this is what we commonly call red tape. It's that tipping point where the effort and cost of following all the rules starts to outweigh any value those rules provide. It's basically the weight of the system working against its own goals. The consequences just cascade from there. Agents lose their ability to use their own judgment, decision-making slows to a crawl, the original goal gets lost in the shuffle, and the whole system just becomes more expensive to run and ultimately less effective at what it was built to do. And it's so important to understand that this decline isn't because of one big mistake or some bad actor trying to sabotage things. It's the logical, emergent result of the system's own internal structure and all the incentives baked into it. So when we put it all together, we can see the entire mechanism as a feedback loop. It starts with growth, which increases the gap between principals and agents. That gap then pushes principals to create rules to enforce control. The one-way accumulation of those rules, the ratchet, creates massive complexity. And finally, that complexity is what produces the dysfunction, undermining the whole point of the system in the first place.
This really reveals a fundamental paradox of complex systems. You can have a whole series of perfectly logical, well-intentioned decisions made at a local level that, when they combine, create a deeply irrational outcome for the entire system. The failure isn't caused by a single person or a specific event. It's an emergent property of the system's own logic. In the end, the system doesn't fail because it breaks. It fails because it's working exactly the way it was designed to.